Good morning, boys and girls. It's Monday, May 4th. Today we're going to be talking about solving systems of equations with substitution like we did last week. Only this week I'm going to throw in some more challenging and difficult problems. Last week's problems were all pretty straightforward. So I call this Part B, Systems with Complications. All right. For this week, I want you guys to, on Monday, I want you to do your Alex minutes, 30 minutes and 3 lessons, and also watch this video, which if you're listening to me, you're clearly already doing that. On Tuesday, your practice assignment will go live on Edge Elastic. You'll have Tuesday and Wednesday to work on that. On Thursday, your Part B quiz will go live on Edge Elastic, and you'll have Thursday and Friday to work on that. As always, if you do less than stellar on either of those, just shoot me an email and I'll reopen it for you. Okay. Let's get started. Let me show you how this can get complicated. In last week's lesson, we were given two equations and they were both already in slope-intercept form. Okay, so what we did was we took this part of it and we set those equal to each other to solve for x and y. So what we would have done here is we would have subtracted 2x from both sides. Again, with the handwriting. And that gives us 10 equals x minus 4. Add 4 to both sides. And we get that x is 14. Right? Now it's easy to solve for y. We just take one of these equations. I'd rather multiply 14 times 2, I think. So we'll go y equals 2x plus 10. I'm going to substitute 14 for x. So y is 2 times 14 plus 10. Y is 28 plus 10. And therefore y is 38. Okay, so the solution is 14, 38. It's an xy coordinate point. That's where they would intersect. So all the problems were simple like this one, okay? This week, not so much. This week, the equations, one or both equations may not be in slope-intercept form, and you'll have to put it in there. Or the system could have infinite or no solutions. So that's how we're going to complicate things this week. Here's our first example. Example number 1. I'm blocking part of my problem. There we go. Okay. Example number 1. We have one equation is in slope-intercept form and one is not. Now you have two options for the most part, but I think you're going to find, like I did, that one option is way better than the other. If you were to come over here and say, hey, you know what, I liked what we did last week. I want to make this problem like last week's. All you have to do is put this equation in slope-intercept form, and then you can set them equal to each other. So you would do that by subtracting 6x from both sides. And that gives you negative 2y equals negative 6x plus 22. Then you would divide each term by negative 2 to get y by itself. And that gives you y equals 3x minus 11. Okay? So now you could do 3x minus 11 equals negative 5x minus 3. Okay? You want to get rid of one of these variable terms. Let's add 5x to both sides. That gives us 8x minus 11 equals negative 3. And if you add 11 to both sides, we arrive at 8x equals 8. And so we pretty much know that x is 1. Well, if we go back up here and put a 1 in for this x, we would have y equals negative 5 times 1 minus 3. Y equals negative 5 minus 3. Y equals negative 8. So the solution to this system of equations is 1, negative 8. That is the point at which the two lines would cross. Now, that is one way of solving it, but sometimes we run into trouble with this method. So this is going to be the method that I think you're going to prefer. Here we have one equation solved for y. We can take this quantity right here because it is equal to y and just substitute it for this y. All right, and this gets super fun because you get to do distributing and you get to do combining like terms, all the stuff we all love and can't wait to do. 22. Okay, so I took this equation, I took out the y, I substituted negative 5x minus 3 for the y. Now we get to distribute. Negative 2 times negative 5 is positive 10x. Negative 2 times negative 3 is positive 6 equals 22. Combine like terms, 16x plus 6 equals 22. Subtract 6 from both sides, and that gives us 16x equals 16. And at this point, we see that x is indeed 1. We could substitute 1 in this equation like we did before and arrive at y equals negative 8. And the solution is 1, negative 8. I think you can see that the system on the right was much easier to solve. So that's the way that I like to solve them. I don't want to waste your time showing you both ways on every problem, but I did set it up on this one. And the reason I did is because I want you to see what's going to happen sometimes that will make you not want to use method 1. If we were going to try to put this in slope-intercept form so that we could solve it like last week's, we would add 5x to both sides, and that gives us negative 6y equals 5x plus 9. All right. Then we have to divide each term by negative 6. Here's where it gets kind of gross, okay, because now we're going to have y equals negative 5 6x minus 3 halves. Fractions are not necessarily fun in this case. You could go ahead and set this equal to 2x minus 10, but I think you're going to find if we use method 2, this is going to solve a lot easier. We're just going to take 2x minus 10 and substitute for this y here. That'll give us negative 5x minus 6 times 2x minus 10 equals 9. So far, no fractions. Negative 6 times positive 2 is negative 12x. Negative 6 times negative 10 is positive 60 equals 9. Combine like terms. Negative 17x plus 60 equals 9. Not pretty, but still not a fraction. Subtract 60 from both sides, and we get negative 17x equals negative 51. And if you divide both sides by negative 17, you get x is 3. No fractions. Okay. Now, if we go over here and we substitute a 3 in here for x, then we would have, let's see if I have room over here, y equals 2 times 3 minus 10. Y equals 6 minus 10. Y equals negative 4. So the solution to this system is 3, negative 4. That was much easier than having to deal with those ugly fractions. Okay, so for example 3. Example 3, what we're faced with now is that neither of these equations is in slope-intercept form. You want to solve for either x or y. All right. Up till now, we've always had y equals something, something. But in the case of this equation right here, wouldn't this be way easier to solve for x? It would. You don't have to solve for y. You can solve for x. And so that's why this problem's here. Let's go ahead and solve for x. If we add 6y to both sides, that gives us x equals 6y plus 24. Okay. Now we can substitute for x. All right. That will give us negative 7 times 6y plus 24 minus 3y equals 12. Okay. Now we're going to distribute the negative 7. Negative 7 times 6 is negative 42y. Negative 7 times 24, I've got that figured out here, is negative 168 minus 3y equals 12. If I combine negative 42y and negative 3y, I'll get negative 45y minus 168 equals 12. And now if I add 168 to both sides, I get negative 45y equals 180. And dividing both sides by negative 45, gives me y equals -4. Okay? So then it doesn't matter which equation I use to solve for x at this point. I'm going to take the x minus 6y equals 24 one because it's a little simpler. Substitute -4 for y. And I get x plus 24 equals 24. And if I subtract 24 from both sides, I get x is 0. Don't get freaked out by that. 0 is a number. All right, the solution for this one is 0, -4. Pretty cool, right? I thought so. So the takeaway from this is you don't have to always solve for y. Sometimes it's easier to solve for x. Next, okay, today's word of the day is frog. Okay, if you've watched the video to this point, when you're finished, comment frog and you'll get full credit. Okay, a couple of Pinterest posts here, how to slap someone through the internet. Well, we can't slap them in real life now, can we? Well, we're not supposed to slap people really, but when your BFF gets a boyfriend and you're thinking of ways to break them up so you can be priority number 1 again, oh yeah. Okay, my last 2 examples are the cases where we're either going to have no solution or infinite solution. This first one has no solution. How would you know though? Well, if you start to solve and you end up with a false statement, that means that this system has no solutions. So look what this is what this would look like. If we're going to take this and we're going to substitute this for y here, equals -4, and y is -2x plus 9 minus 12. Don't forget that little minus 12 on the end there. 8x equals -4 times -2 is positive 8x. -4 times positive 9 is -36 minus 12. Well, if I combine like terms, 8x, and already your math brains are going, this doesn't look right. How can 8x be equal to 8x minus 48? It can't, right? If you subtracted 8x from both sides, you would get that 0 is equal to -48, which we know is not true. Therefore, this is a false statement, and this system has no solutions. You're going to like these real well because they're a lot less work. So, false statement, no solutions. This is an example of one that has infinite solutions, okay? Why does the light keep getting weird on this? All right, we're going to do the same kind of thing. We're going to substitute for y. We have 15x plus 3 times -5x minus 5 equals -15. 15x, distribute. 3 times -5 is -15x. 3 times -5 is -15 equals -15. 15x minus 15x is 0. So that gives us -15 is equal to -15, which is a true statement. So this system of equations has infinite solutions. Okay. All right. So this page here, these are 3 sample problems. What I would like you to do is pause the video, do these 3 problems, and see what solutions you get. I'll wait. Okay, if you played along, these are the correct solutions to these 3 problems. The first one, the solution is 1.1, -7. The second system of equations had no solutions. It resulted in a false statement. And the last one had infinite solutions. It resulted in a true statement. All right, so that's pretty much what we're dealing with this week. Still solving systems by substitution with a twist. All right. You guys have a great week. All your stuff will be on Edge Elastic as always. And thanks for watching.